Hello, everybody. Welcome to the Lausanne School of Engineering. My name is Jane Goodyear. I'm the Dean at the School of Engineering, and it's my pleasure to kick off today's event, which is the GIS Day at York University. But before we do begin our, our thing today, I'd like to take a moment to actually give York University's formal land acknowledgement. And I'd like you to take a moment because given the ongoing COVID-19 pandemic, many of us are dispersed across the Toronto GTA and also beyond. And despite this new way of remote working, as a school, we feel it's important to acknowledge the land where we are. And hopefully sometime very soon in the future, we'll be back together working and teaching and learning on campus. So fingers crossed that happens. So I just want you to take a moment whilst I do say the land acknowledgement and to reflect on what that means for you and where you are. So York University recognises that many Indigenous nations have long-standing relationships with the territories upon which York University campuses are located that precede the actual establishment of York University. York University acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation, and this territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peacefully share and care for the Great Lakes region. And whilst that's our formal land acknowledgement, at the Lausanne School of Engineering, we are really dedicated to having a community that is engaged with equity, diversity and inclusion. And as the leader of the school, I'm actually going through a learning journey myself in various facets of being an inclusive leader. And so what I want to share with you today is every time I do a land acknowledgement, I am trying to learn more about the Indigenous communities that are a big part of Canada and its life. So I'm just going to put in the post a research paper that I've actually looked at, and it's called The Unavoidable Expertise, Technocratic Positionality and GIS Science, Eliciting an Indigenous Geospatial Ontology with the Eastern Cree in Northern Quebec. And I do urge you to, I'm going to put it in the notes, and if you could take a moment to maybe read that at some point. I've done my job today to help us become a more inclusive community. So that being said, I've been asked to welcome various people. So let me just get my notes here. Do hold on a moment. Okay, so I believe GIS Day has always been a great opportunity to discover, to celebrate and understand the benefits of geospatial technology that is around us in our daily life, and it really does make a difference to our society. For instance, I know Modggan has been helping with this, tracking on how the coronavirus is spreading through our communities. It's helping us track our shipping of our favourite Christmas gifts to our family across the globe. So there's various facets GIS is part of our daily lives. And as a tradition of each year, we're going to celebrate GIS Day at York University, and it's hosted with us, the School of Engineering, and the Geomatics Club, and the Institute of Transportation Engineers, York University Student Chapter. So thank you for co-hosting this special day. And I'd also like to welcome some key special guests. We have Dr. Michael Leary, who is from ESRI Canada. Welcome, Michael. I'm looking forward to hearing more about what you've got to say. And Mr. Medrad Varidi from WaterLix Inc, and followed by Eros Gulo from Mapsted Inc. So welcome all. I'm sure our students are really excited to hear about what you're going to say. So that's my introduction to the school. A very, very warm welcome to Lausanne School of Engineering, and I really hope this event goes well today. Thank you.
Okay, I'd like to take it from here. Hello, everyone. My name is Ryan Nguyen, and I am a third-year geomatics engineering student, and I'm also the ambassador of the Geomatics Club. On behalf of the Geomatics Club and ITE, I'd like to say thank you to everyone who is attending and the guest presenters. I'd also like to thank the professors and the clubs who have collaborated together to organize this event. The Geomatics Club and ITE are offering 5 $20 Amazon gift cards, as well as 5 ArcGIS one-year licenses, and I believe also 1 WaterLix license as well. To participate in the raffle, please vote in our poll with a link provided in the description, or use the QR code on the slides on which raffle you'd like a chance to win. You cannot, however, participate in only in one event, so choose carefully with which prize you'd like to win. We will announce 2 winners of each raffle after every presentation, so stay tuned. I'd like to introduce the president of the Geomatics Club, Gurjit Mahant, to say a few words regarding the club.
Hi everyone, my name is Gurjit Mahant. I'm the president of the Geomatics Club. The Geomatics Club at York University is one of the oldest student clubs at Lausanne, and are always looking forward to increasing our team. Our goal and motive is to provide support to students and to foster a collaborative community among our geomatics students, faculty, and industry leaders. Throughout the year, we organize events such as GIS Day, GeoMixer, and our annual career fair, which last year was called the Industry Night. We also help organize the logistics to send students to compete at the National Geomatics Competition and to attend the annual general meeting for the AOLS. So thank you very much. I hope you enjoy GIS Day.
Next person I'd like to introduce is the president of the ITE student chapter, Tim Young. I'm sorry, Tim, I don't think we can hear you.
Of course, I had my mic muted, apologies. Welcome everyone. My name is Tim Young. I'm the president of the Institute of Transportation Engineers, York University Student Chapter. We are York University's community of transportation professionals, hosting seminars, software tutorials, and in better days, field trips, volunteering, and other social events. Some of these are member exclusive and membership is free. If you're watching on YouTube Live, you're also on our live stream YouTube channel. So thank you for joining in. If you are interested in more things related to transportation, feel free to check us out on YouTube or on campus groups. More on that later. It's a pleasure and an honor to help host GIS Day with the Geomatics Club, and we look forward to what is ahead. Thank you.
Okay, let us begin GIS Day. With our first speaker, we have Dr. Michael Leahy. Michael is a higher education developer / analyst in the education and research group at ESRI Canada. Michael has a PhD in geography from Wilfrid Laurier University and a master's in environmental studies from University of Waterloo. So, Michael, the stage is yours.
All right. Thank you very much. So I'm Michael Leahy. And what I want to take this time that I have today to do is to talk about developing applications for ArcGIS. So I'm glad I've got this opportunity because I know certainly a number of you use ArcGIS for a lot of things, but there's also one of my motives. If you don't know me, I'm also the administrator of the ESRI Canada GIS Centers of Excellence. We have 11 schools across Canada, and York University is one of those. And one of the things we do each year is we have an app challenge where we get students at our schools to participate in teams to build applications with ArcGIS each year. So while this is kind of my underlying motive or motivation for what I'm talking about today, the app challenge is open to all students at these schools, but developing applications for ArcGIS is something that anyone may be interested in doing. So everything I talk about pretty much after this slide is applicable to you, even if you aren't considering participating in the app challenge. So if you're not familiar with the app challenge, it's a 1-week team-based competition that we host each year at York University and 10 other schools. In this challenge, teams of 2 to 3 students are tasked to develop applications for a specific topic or theme using open data and ESRI technology. Now that can include other types of data or integrate with open source technologies, for example, but the open data and ESRI technology need to feature prominently. And then around that, the team needs to develop their own mission statement, associated documentation, and develop a video that presents and demonstrates their application to end users, and in particular, the judges for the competition. So as I noted, this is open to all students at ECCE school. So if you're a York University student, you can participate in this. If you're interested, you should talk to Modgen or Costas. They're your directors of the ECCE at York University. Excuse me. And then the dates for the app challenge are decided at each school, and they take place generally between late February and early April. So you'd want to coordinate with your directors on that. Normally the grand prize for teams that win this competition is a trip to San Diego. That obviously didn't happen this year. It's probably not going to happen next year. So if that ends up being the case again, then we substitute with an alternative prize, likely a cash prize of appropriate value. One of the things I want to emphasize for this, and that this may not apply to you specifically, but certainly a lot of people I'm aware choose not to participate in this challenge because they think it's solely a coding competition. We do like seeing students that get involved in developing custom applications, writing their own custom code, and seeing what they can create, but it's not required. And there's really 2 ways around that in this competition. Since it's a team-based competition, you can get yourself together with other students who can write code. And as I've mentioned before, there's other things that you need to do around the development of the application that require a lot of work as well. So you don't necessarily need to be the person writing code on a custom application. The other alternative is to use many of the tools that we have available in the ArcGIS platform that let you create highly functional and unique applications without writing any code. So the platform I'm talking about, ArcGIS, is really, it's basically a web GIS that has an ecosystem with ArcGIS Online or ArcGIS Enterprise at its core. Most of you would be working with ArcGIS Online and you have your accounts available to you from your schools. And then there's an ecosystem of applications around that. They can be ArcGIS Pro on your desktop, City Engine, mobile applications on your phones or tablets, or applications that run in a web browser. And in addition to that, you can develop any application you need with a variety of APIs and software development kits. So keeping the app challenge in mind, there are several development patterns that you can take for creating an application that you would submit as a project. If you're someone who doesn't want to write code, there are many options available to you to simply configure or build applications through configuration without writing any code, of course. And I'll mention those in a moment. Your next option, if you've been working with GIS or similar applications on your desktop, you may have already been developing skills with scripting and automation. This isn't something that normally features prominently in App Challenge projects, but I'll talk about how you can incorporate that. Then stepping into actual sort of development of applications, but without having to write a whole lot of custom code, you can actually take some of these applications. They may be in the category of configuring and building an application, but in a number of cases, you can actually take the source code of those applications that you've built and get access to that code and make small changes to make it unique and different, add your own custom functionality. And that way you don't have to write a lot of code. You can come up with some interesting applications that are unique without doing most of the work up front. But if you do want to develop your own applications from scratch, then you can, of course, do a full custom development application from the ground up. And there's a variety of ways or tools available to you to help with that. So with that in mind, if we look at the first option, configuring and building apps, if any of you have worked with ArcGIS Online up to this point, you've already been creating web maps. If you've worked with ArcGIS on your desktop, you'll recognize if you're working with a map document or if you have maps in your project in ArcGIS Pro. Those items don't store your data. They are documents that describe where your data exists, how they should be brought into a map, and how they should be displayed. A web map is the same thing. It just lives in ArcGIS Online. It describes where on the internet you would be accessing data for your layers and how they should be presented by an application in a map. And once you've composed one of these web maps, you can then share it either just as a map on its own, or you can create dashboards that show data within those layers in your map, or you can share through template web applications that give you options to configure their behavior, or you can more or less build an application from scratch using Web App Builder. And that's where you can choose a theme and one of a variety of widgets available, and you customize how they work using your maps and your data. And if you want to take things a step further, you can bring your data into Insights for ArcGIS, do analytics, build reports, share those as interactive views into your data. If you want to build story maps, you can create a narrative and develop a story around your maps and have that in an integrated interactive document that communicates what you want to say to your audience. And then Experience Builder is kind of like the next version of Web App Builder. That enables you to design a web page almost from scratch, but again, without writing any code, and bring in your maps and data in a very interactive environment. And just to emphasize, for those of you that are wondering, you can win the App Challenge without writing code for a custom application. In 2017, some of your former peers at York University won the App Challenge. They built an application with Web App Builder and developed the rest of their project and their video around that. And that got them to come with us to San Diego that year. All right, now if you're into scripting and automating, you might be writing code, although not necessarily. If you're using, for example, Model Builder, you can create graphical processes that represent your workflows and have inputs and outputs and allow you to repeat your processes and share those. You might be writing some code, perhaps in Python or maybe even R, where you're working with your data in this environment. And if you want to share those, it's possible to create custom geoprocessing tools that run your tools, but prompt users for inputs and display the outputs. Now, again, I mentioned this isn't something that features prominently usually in the App Challenge, because usually we're looking for some kind of application or a web mapping interface that we can show people. But something you'll want to take a look at if this is your comfort zone, to do scripting and geoprocessing on your local machine is to look at ArcGIS notebooks, which combine Jupyter notebooks with the ArcGIS Python libraries. And in this environment, you can do all the same coding that you would have done in Python with ArcGIS on the desktop, but surround it with rich text, multimedia, and interactive views of the input and output data that you're working with. And so keep that in mind. I'll come back to this towards the end. But what these notebooks do is essentially the way, if you've used ArcGIS story maps, they take your regular maps and they enable you to tell an immersive story around those. The same thing works with ArcGIS notebooks. They take your regular code that may do something really complex, but is difficult for someone else to understand. You can present that in an interactive and fluid document that communicates what's happening in your code and explains and lets people interact with the data as you're working on them in the notebook. So again, keep that in mind. I'll come back to that in a moment. Now, if you're looking at doing a little bit of coding, but you don't want to write in a complete application, then you're looking at options for essentially extending or customizing ArcGIS applications. So on the desktop, of course, if you create and share custom geoprocessing tools, you're essentially extending the geoprocessing framework in ArcGIS. If you want, you can extend ArcMap or ArcGIS Pro with embedded add-ins. But most likely what you're going to be working with, if you're thinking of the app challenge, is this group of applications here. This is App Studio, which enables you to create native applications that work across most devices. Or on the web, you have Web App Builder, Experience Builder, and the out-of-the-box web app templates from ArcGIS Online. All of these give you a developer access to the applications you create. So you can use them as a shortcut to get, through simple configuration, a fairly complete application using available templates. But then dig into the source code and maybe there's some small changes you want to make to do something unique. You can do that within these, basically get 90% of the way there without writing code, and then make some small modifications to create a unique application. And certainly a number of teams in the past have used this approach. And then your last option would be to do a full custom application. And this is where you're writing the entire application, but when it comes to integrating with ArcGIS, you have available to you a variety of APIs and software development kits that save you the trouble of writing all the code that manages layers and creates map interfaces. These are objects that you can bring into your application and use them quite easily. Most of the time, you'll be working with the JavaScript API to do a web mapping application. But if you want to develop something for any other platform, then you have runtime SDKs available for that. And just as some examples, we have the winner from 2018 did a custom web mapping application with the JavaScript API from Simon Fraser University. Last year, the team from University of Waterloo that won created a mobile Android application. So those are examples of fully custom developed applications that did win for the app challenge. Now, those are the 4 general approaches, but you don't necessarily need to choose one for the app challenge or for any other project you're working on. You can certainly combine multiple approaches, and teams have been doing this in many examples. So remember, I was talking about the notebooks. Quite often, as you're preparing your data and your services that you're going to use in your application, there's a lot of work that goes into that. And part of your project can easily be represented with a notebook that tours someone through all the steps that you took to collect and prepare your data and create the content that you use in your application. And then you can combine that with a simple configured application from Web App Builder or Story Map. And then you have a fairly complete story or project that you can share that is steps beyond just showing a map or just showing one story map. You can actually show a much broader context to your project. So as an example, this particular approach was used by one of the teams this year from University of Toronto. And a similar sort of approach was used by the team that won also from U of T. They created a out-of-the-box web app builder application and combined it with their own custom developed web page. So it was a little bit of two different approaches that they put together. And so that got them to win the competition overall. And then you'll be hearing a little bit later from one of the runner-up team that was also from York University a bit later. So if any of this interests you, or if you're thinking of participating in the app challenge this year, there's lots of resources you can use to get started. You're welcome to contact me anytime if you have any questions. Anybody at a university that has an ArcGIS license can get access to all of this. And pretty much most things I've talked about today, you can access with a free ArcGIS developers account, which you can take with you after you're done school. And if you need some inspiration, I'd encourage you, in addition to the students you'll hear from today, you can go back and look at least the past 4 years. You'll see detailed profiles. You can see the video recordings and the live applications that were submitted in previous years. So that's pretty much what I wanted to say. I hope I've inspired some of you that might have been hesitant about the app challenge. And I look forward to seeing some York University teams coming back next year.
Yeah,
questions?
thank you, Michael. So yeah, if anyone has any questions, if you're watching from YouTube, you can ask on the YouTube live chat. If you're on Zoom, there's a raise hand option in the participants list. And Azmeet will address the questions. So any questions for Michael or on his presentation, feel free to ask.
So I see one person in the chat. Okay, two people. One asked if it's possible to look at the U of T project. That was my previous slide. We have a GitHub repository that we use to showcase all previous applications. The first 2 years, it's just their source code. From 2017 onward, it's a full team profile with their videos that they produced, and the applications where possible, they're still live. Next person is asking where to sign up. So if you're at York University, you're going to be talking to Majkin Jadidi or Kostas Armanakis. They're the two directors of the Centers of Excellence at York University. If you're not sure, you can contact me. I can get you in touch with whoever's directing the Center of Excellence at your school. And if there's anyone asking questions in YouTube, I don't see them. Right.
Hi there. I'm monitoring the YouTube chat, and I actually have a couple of questions from here.
Okay.
So Abdullah Rizvi asked, is there any financial support from the university for any of these challenges?
I don't believe so. There's the grand prize that everyone can win. You get yourself showcased regardless of whether you win. Everyone gets a profile and a showcase in our repository. And in terms of support, you have access to all of this software. If you don't know how to get it, we can help you with that. And then for technical support, you can talk to people at your school, but certainly I'm available throughout the app challenge when it takes place.
Awesome, thank you. And I have another question from YouTube as well. Is the app challenge only in Canada or all countries?
It is at ESRI Canada GIS Centers of Excellence. So there's 11 schools across Canada. So you would need to be a student at one of those to participate. And if you're not sure, you can head to ecce.esri.ca, and there is a webpage that lists our schools there.
Awesome, thank you.
All right.
Okay, if that's all the questions, and if you don't have a question now, maybe you'd like to ask later, Michael's email is right there.
Yep.
So take a screenshot. And now I'd like to announce the raffle. So if you guys have not entered the raffle, I'd say, enter now before we start picking a winner. I'll give it some time, and we'll announce it soon. How do you enter? Okay, I guess, Tim, I guess if you could take back the share screen and hopefully share the QR code if people are still watching, along with the link.
Hello?
Hello, hello.
Excuse me, is it my turn or?
Oh no, we're just waiting for
Okay,
people to apply for the poll, and
all right,
hopefully Tim can take back the
okay.
screen. Yeah, just a little moment. Yes, there is a QR code for the raffle. I'm just waiting on Tim to just share the slides, if you could.
I can't hear you, Tim, but do you need me to stop sharing?
No, we're all good over here. Ryan, are you ready?
Yeah. People just want to enroll in the raffle though, so if you could just share the.
I think what we'll do is we'll come back and get them in the next round. We've got 5 rounds. Each one we're giving away one of the Amazon gift cards and one of the ESRI licenses. So make
Okay.
sure that you sign up. We'll get you in the next round. We've got the ones
Okay.
for round 1 ready, I believe.
Okay, so we do have the winners for the round ones. I just want to wait. So, okay, for the winner of the Amazon gift card, the winner is Janelle Aziz. So, congratulations, you won the Amazon gift card. And for the ESRI ESRI ArcGIS license, the winner of that is Jared Yen. So, congratulations, Jared.
I couldn't get the other one up in time. We went too quick. All right, I'm going to go back to the raffle entry so that you guys can scan that QR code. I'm going to try and also get that link up in chat. If someone could type that up in public chat, just so that everyone else can enter for the other rounds. All right, and I guess we'll get everyone in the next round.
Okay, so our next presenter for that we have today is Mehrdad Veredi. Mehrdad is a founder and CEO of WaterLix. He's an entrepreneur and provides digital solutions for water utilities in his company. He has a background in mathematics, computer science, and a master's degree in management science. So Mehrdad, the stage is yours.
Thank you very much for the opportunity that the University of York gave me, and also thanks to Dr. Mushkan Jadidi for inviting me. I'm here to share with you two things. One of them is one of the applications that WaterLix begin with. And I will give you some explanation that how what was the problem that we solved. And also at the end, I'd like to talk a little bit about open data and its importance, and how and why I think that everybody should get involved in releasing more data and making some efforts, because yeah, we'll talk about it later. But let me share my screen and okay. If there's any problem with this screen, let me know. I know what to do to solve the problem. So I'm sharing it. Can you see my screen right now?
I don't think we can.
I don't think so. Michael, could you stop your screen share, please? There we go.
Can you see?
We can see your entire screen right now.
So this one.
Everything, including your desktop. Beautiful desktop background, by the way.
Oh, thank you. So yeah, so this is, all right, so you see two monitors or only one?
Just one, just the one.
Okay. All right, so I hope that this will be the one that you see. So I play from start. Okay, can you see this? Are we going to replace all pipes?
Yes, we see the PowerPoint editing interface.
Oh, the editing, the other one.
Now we got it. Now we got the full screen. We got the full screen. Beautiful.
All right, great. So yeah, so the problem that we tried to solve in WaterLix was this old infrastructure challenge. Cities were reporting that, hey, we have a financing gap. We have a lot of old pipes and we need to replace them to fix the leakage problem, which is really a big one. I mean, how big? Around $3 billion a year, just the worth of water and energy that is wasted in Canada only. So this is a huge amount of thing that people will pay for it. And it has a lot of other consequences, like pollution, like impact on other infrastructures. So the pipes near that will be affected if there would be a water leakage. The pollution will be washed out into source water. So all kind of bad things may happen, but we need to stop this problem. But cities say that, hey, we have a financing problem. We have so many old pipes. We look at it and we ask the question that, okay, so if we know that these old pipes are making a problem, so how much problem do they make? For example, if you replace one pipe, one water main, how much of those costs for us will go down? I asked this question in a technical team, in a technical group for water leakage in AWWA, ACE conference in Philadelphia, and said, do you know what will be the ROI of the project that you did last year? And the answer was, nobody can say this thing. I said, I don't think it would be right. So in order to solve this problem, I mean, finding out which pipes need to be replaced and which pipes actually are feasible to be replaced, we developed a model. One additional thing that we used here, and it's different with the other models that are developed so far, is that we paid attention to the geography, and we thought that the points of leakage cannot be everywhere. These leakages only happen on specific points, and we need to study and see and find some connection between, for example, vibration on roads, for example, on wetness of the soil, for example, on the type of the soil, and so many other factors. So in the beginning, it was just a consultant job. And later we developed the software for it. The benefit of the software definitely is the time. So things that could have been done, I mean, you should have worked on that for 4 months, 6 months, or as much as you want, and now it can be done in half a day or even less. So you may say that, okay, so you're removing some jobs. No, actually, we allow the people to focus on what they have to work on. We did the separation of concerns. We created 3 different applications, one for data preparation and data engineers, one for data analysis and modeling, and one for decision makers that make them enabled to decide on their own. We don't need the analyst. The analyst doesn't need the person, the data engineer all the time. When their job is done, they just pass something to the next person. And then how it looks like. And so this is, okay, this is how it looks like. This interface is for uploading the data for processing. For example, in this page, you see a map for water mains that we have uploaded that. And in this map, you can map the fields that you want to the necessary fields for modeling. You can easily map that without touching the file. Everything is kind of automated. You can see how many pipes do you have. I mean, what type of pipes you have, or the length of the pipes, or the details of each pipe. And also you can do the same thing for water main breaks that you want to detect them and actually pinpoint that, okay, where we may have the next water main break. And you can upload them. You can see a graph and make sure that actually your data is okay. When it's okay, you can process them. Here, you can add any geodata that you want. Any raster file can be uploaded. So for example, if you want to see the effect of methane sites on breaks in a city, you can upload the methane raster file. You can analyze the effect of trees on breaks. So upload that file, but in form of a raster file. And then this thing can be included in the data that will be passed to the next person, which is the data analyst. The data analyst gets the data, upload that, and this is the screen that he will get. Here he can filter out, filter some of the pipes, because we're not going to model all the pipes in a city, and we cannot actually do it with this approach because we're looking at numbers. Consider that we don't have any breaks, or we have a couple of breaks on a specific type of pipe. For example, on a PVC of size 300, you have only 4 breaks. Okay, so what kind of model I can build for polyvinyl PVC size 300? Well, we need to build a model. We need to train a model. We need to test that model. So with 4 breaks, I'm not going to be able to do that. So first of all, we filter on the pipes that we want to enter into our decision-making process. And by the way, when a pipe does not have so many breaks comparing with the others, maybe it's better not to think about that as a really big problem. So when it's done, then the person can come and write down any formula or any kind of relationship that he wants to study between the breaks and the independent variables, and that is passed into the data set to him. If the model works well, the details will be seen in a different page because of the time. I haven't included everything, but if it works well, the analyst can ask for generating the condition map. When they generate the condition map, it will be passed to decision makers. Decision makers will get a page something like this. So I don't know if I can show you, but I might be able to now show you the application itself. Can you see something right now? Can you see the application?
Yep, working perfectly.
Okay, great. So as you can see here, the decision maker can select the top 6% of pipes that is making a problem here. So I select the 10%, right? I select 10% of top priority pipes. What do I mean by that? This 10% actually covered 90% of breaks. 91%, it's refreshing still. Or some percentage of the breaks on the selected subset of pipes. So for example, we have selected 24% of, in the subset that we've selected in this case, a quarter of pipes, a quarter of breaks are happening in this subset. So when we say 91% of a quarter, it means this much of pipe, this much of reduction, something near a quarter of breaks will go away if you replace 10% of pipes, high priority pipes in here. If you, for example, okay, so in here, you can take a look at the ROI of this project. So we'll have an ROI of 295% in 10 years if the project takes 3 years to be completed. So you have some pipes to be replaced, and if this project would be done in 3 years, we have 295%. What if we could actually finish everything in the first year? So the ROI goes up. So they can see exactly the effect of the length of the project on the ROI and decide that, okay, do they want to go ahead with 1 year project or a shorter period of time? So here, as you can see, that ROI that they couldn't calculate, it can be calculated very easily. Also, they can see the pipes that they need to replace here. They can zoom in. They can just, of course, switch on ESRI world map, see where these pipes are, or you can switch to OpenStreetMap and see, okay, what is the name of the street, or see all the details. Also, you can download the condition map for the select pipes, or even download a summary report for this scenario that they've selected. So it generates a Word file for them, and they can get a report to work on, and which has all the details that you can see here, including the list of pipes that need to be replaced, and all these options that they've selected. Here I want to, for example, change 10% to 6% and look at this 308. As you can see, the ROI changes as you change this value in here. And I think the 10% had the ROI of 308. Now for 5%, still we have 308, but the break reduction is 72%. This is in case that you want to find out for which percent you get the maximum ROI. In case of 6% of the network, we even get a higher ROI. So it's better to, if you want to assign a budget, and we have, for example, sewer pipes, we have water pipes, different projects, we can take a look at the total cost that each of these has and look at our total project available, and then decide about whether to go ahead with this project or not. So this was just some explanation about how this is working and how this may help people. But let me go back to I wish that selected something else, but all right. So this was our project. We have implemented it in the city of London and city of Guelph, and we've used the data in city of Kitchener. We were lucky to be selected as top 15 projects. The project with the City of London was selected as top 15 clean tech project in 2019, and Ontario Centre of Excellence and Sengen invested in in our applications and supported us in the past 2 years, each with $50,000 reward. And thanks to all of them, of course, the team that worked on this. But I want to say that one of the most important things that I should mention is this lady here. She's not part of the WaterLix apparently, but she's the person that played a very big role in WaterLix. Without her, WaterLix didn't exist. What she did, she helped me to have some data as open data in City of Kitchener. I asked her anything and she released the data for me. She actually went out of her comfort zone. She insisted on releasing the data that usually is mentioned as, oh, it shouldn't be published. These are affecting the security of city, or so many stories and behind. Although she knew something and she believed in something, that okay, something is changed and we need to share the data. And the things that are changed is partly, you know, and you're well aware of it, the data revolution, the processing power of things, so many data around us. Yeah, that's very good. But another thing is also changed when you compare today with 50 years ago. 50 years ago, we had just few people that were engineers and well-educated people. And we were asking these people to go to these big buildings and decide for everybody. Since those days, we have now majority of the people that are educated outside of these buildings. Although still we have a lot of more data comparing with 50 years ago. But all of that data usually is locked in these big buildings. Other than having all of these data in hand of everybody, the processing power are outside of these buildings. So people in the government are expected to actually select the best or implement the project rather than making decisions, I believe. And open data is a step that it allows the people this opportunity and gives you this opportunity, experts like you, to take a look at the data and solve the problems, something similar with what I saw. So I believe she did the most important thing in here, and I believe all of you can do that, because very soon you will be in her position and in top positions, and you have opportunity to think about this thing, release the data, share the data. And this is a key thing. When you look at, for example, the health data, what if all of us had access to COVID cases, or just to health data in general? Couldn't we really figure out the pandemic as it was happening earlier than this? Couldn't we actually be more agile than the government or governments around the world? When the data is available, we can do much more than that. People donate their bodies after death. But what if we had a procedure that they would donate their data to share with the people to go and do research on that, with the hope of actually saving some more people, rather than just keeping everything as private. Yeah, privacy is very important, I understand that, but there might be a lot of people that they want to share their data. We need some processes and procedures to have these data out in the hands of researchers. Why only few people, again, in these big buildings are capable of processing some, for example, cancer information? I believe that the processing power outside of these buildings and people, all the educated people, can make a really big change. Canada spends $250 million, for example, and every year we give this money to other companies to stay here and to have some to keep the jobs in Canada. What if we could actually generate more jobs in a different way? We're just sharing the data. We're just changing things in this way and paying attention that, hey, now not all the processing power are still in the same place that it used to be. And thank you very much for the opportunity, and that was it.
Thank you, Merdad. Merdad, do you have like an email or anything if anyone has any questions for you, maybe after
Sure.
the presentation?
Sure.
Yeah, so if
Yeah,
anyone has any
Varadi,
questions,
yeah.
oh, sorry?
Yeah, Varadi@waterlix.com. VAREDI @waterlix.com. Can I type it somewhere here?
I guess you could probably put it in the chat so people can remember.
Okay.
But if anyone has any questions now, you can anyone can ask in the YouTube live chat or the Zoom live chat. You can raise your hand, and Merdad would be happily to answer it.
Sure, I hope.
Check the YouTube as well. Okay, I guess if nobody has any questions, thank you, Merdad.
Good.
We're gonna continue. Wait.
So have a good day.
Oh,
Thanks for
Merdad.
having me.
Oh, I think there's a question for you in the Zoom chat. Maybe you could address this.
I cannot see the question. Sorry.
Okay, I'll read it for you then. Thank you for the information. It's giving me insight on how people need to be open to sharing data just as much as people are willing to give their. Oh, okay, it wasn't a question. Okay, I'm sorry. Okay, so, anyways, thank you, Merdad. We'll continue on to the raffle then. So, for round two, the winners of round two is for the $20 gift card. Abrar Noman has won the Amazon gift card. For the ESRI license, Aliyah Abbas, hopefully I'm saying these names right. Aliyah Abbas has won the ESRI license. So congratulations. And also, I'd like to ask if anyone who's watching is works like in the city or in an office, a municipal office, you might be eligible to participate in the WaterLix subscription, happily provided by Merdad. So if anyone wants to, I guess, mention themselves in the chat, please do so, and we'll hopefully arrange something. With that said, we're gonna take a short break. I think 5, maybe 15 minutes or something like that, and we'll resume with the next speaker. Okay? Thank you, everyone.
Thank you.
Okay, welcome back, everybody. Tim, I think there's an echo on the echo. So, could you fix that, please? Testing. Yeah. Uh, Tim, there's like an echo on me. Okay, hopefully is this better now? Do I sound better? Seeing some nods?
You're good.
Okay.
You should be good now.
Okay, all right. Welcome back, everyone. I'd like to continue along with GIS Day with our next guest speaker, Mr. Eros Gulo. Eros is our very own alumni who has graduated from geomatics engineering at York University in 2013, and he began his master's in geomatics science in 2014, which he has completed recently in 2020. Now he's on the process of earning his professional engineer designation. So, Mr. Eros, the stage is yours.
Thank you. So let me just share my screen here. There's an awful lot in the presentation, but at least you can give a recap of what I'm talking about. So can you guys see just my presentation now? We're all good?
Yeah, we see it.
All right, great. So my name is Eros Gulo, and I'm part of the research and development team at Mapsted currently. And I guess I'm going to talk to you guys a little bit about like what was my experience like first at YorkU, both in during my bachelor's and in my graduate studies in my master's, as well as working for a startup tech company afterwards. And so hopefully I'll give you guys a little bit of insight into all of that. So firstly, my bachelor. So I did geomatics engineering at YorkU, and I finished that actually in 2013. So I actually started in space engineering at YorkU because, you know, while I was finishing up high school, I was really excited about aviation and aerospace. And, you know, space engineering was kind of related, and I got into that at York. I got into the program and I came in. And at the time, I actually had no idea what geomatics was. And still a lot of time when I explain it to people, they're kind of confused. They may have never heard the word before, but it's actually very interesting because geomatics is actually such a wide subject and such a wide field that you actually have multiple different disciplines in it. And so it was very interesting for me when I did discover that. And, you know, I was very excited to change my program. And then, so after my first year, I changed to geomatics and then ended up finishing it over the next 3 years. So what I want to say, I guess some of the main disciplines, I mean, a lot of you guys will already know because you'll be from geomatics, but those of you who aren't in the program or not familiar with it, it covers everything from GIS, which is, you know, what today is about, to surveying, remote sensing, some computer vision in terms of like determining, you know, both the inside of buildings and the outside, in the outdoor space via images, video, and so on, and as well as positioning. So things like GPS and how that works and all the other global navigation systems. And so it's a very nice blend of, I guess, math, physics, geodesy, geography, computer science, all of that. So I found it very, very interesting. And, you know, I hope to turn some people towards it and to make the program a little bit more popular. And I do want to say, though, it was very difficult. As interesting as it was very difficult. But, you know, it was a good time. So after that, I finished that in 2013. And then that summer, I had the fortune of, you know, getting in touch with Professor Guno-san, if any of you guys are familiar with him. And I found out that he was looking for a master's student because at the time I had no intention of doing any graduate studies and I was looking to go straight into industry. But he got in touch with me and he had a pretty exciting research opportunity. And so, you know, I took the plunge and started my master's. So my research focused on indoor positioning using mobile devices, so things like your smartphones. And basically the reason why that is a field of study is because indoors, we don't really have access to GPS signals. And so trying to position via GPS is very difficult, if not impossible. And so there's multiple different methods and, you know, whole field of study into how we can get accurate positioning in the indoor space. And so part of my master's, I also did some courses in more advanced GIS and as well as software development, because I knew at the time that I wanted to learn more programming and development skills so that I was ready to apply all my research skills in industry once I was out of my master's. And in addition to that, I also got a chance to do a small side project with industry, which was a company called Nearcom, if anyone's familiar with them. And over the course of my master's, I managed to both design a system and build it where you were able to get indoor positioning across a few different buildings at York University using your mobile phone. So as I was getting close to completing my master's, a friend of mine actually happened to come across the company that I work for now, which is called Mapsted. And they showed it to me and they're like, hey, this sounds exactly like what you're doing your research on. And so, I thought, why not? I applied to it. And all of a sudden, I was offered a job because I really fit perfectly in with them. And you'll see shortly when I describe them. And so actually, just before I was able to write my thesis and graduate from my master's, I ended up getting a job there. And I was thinking, hey, I'll be able to finish this on the side. And so, I tried to continue part-time, but that didn't actually turn out to work. And so a few years had actually passed for me working at the company before I, decided to really, concentrate again this year. And I reinstated as a part-time student and I finished my thesis and whatnot. I wouldn't necessarily recommend the path I took. I would definitely recommend you finish your graduate studies before looking for a job. But in my case, it just turned out to be an opportunity that was, almost perfect. And so I did take it. But in any case, let me explain a little bit more now about the company that I work for. So the company is called Mapsted, and I guess the main thing we do is that we have advanced positioning and navigation technology. And now this would be needed, as I said, in indoor spaces. So large buildings like malls, convention centers, think of hospitals, airports, things like that, where GPS positioning is not quite good enough and you won't necessarily have the kind of resolution and positioning that you would need in order to get useful location information. Right, so we developed, a very advanced system where we use basically any data that is available on the smartphone to, to position the user, depending also on what's available at the, at the venue. So whether it's wireless signals, whether it's the inertial sensors on a phone, anything that's available, we have developed algorithms to try and take advantage of everything and to make our system very, robust, essentially. So as part of that service, we also do mapping of buildings. So for example, we'll take, whatever the client will have, whether it's, simple floor plan or lease plan to kind of, drawn map, if you will, like a pictorial map. And we will convert that into our system in order to be able to use that map for positioning. And in addition to that, we use our positioning technology and once it's deployed, in order to get location-based services going. So things like marketing, depending on your location, or particular services that are location-based, we can offer that through our platform. And as well, from all the different users that may be using our positioning and navigation app on a venue where it's deployed, the client, so which would be the venue owner or manager, property manager, they'd be able to get, for example, occupancy statistics or visitor analytics to see, where people are, where they've, what their paths look like when they visit their mall, let's say, right? And I also want to highlight that our company is very research intensive. So from the very beginning when I joined, it was a couple years old at the time, but they've been very, very strong on like, we must develop new technologies, we must document it, and we've applied for countless patents and we've created countless, new technology, right? And that work has paid off. Like, I think actually we're even above 60 at this point, granted. I believe our website has 60 and 55 in progress, but I think we're closer to maybe 80 granted and another 40 or 50 still in progress. So we've also added, we've been very, very busy in that sense. So, and the final point is that we have hired York alumni. So outside of myself, there is another geomatics engineering graduate that works for our company, as well as someone who I believe graduated from geography, but had their GIS certificate. And she also worked at our company for some time. So, you know, the programs at YorkU fit right into, you know, the kind of employees that our company looks for. So I also wanted to go a little bit more detail about, you know, my experience there and what it's like working at a startup. So, and a lot of these things that I mentioned here, they're not really specific just to my company. You would find this in most technology startups or even smaller technology firms. So I started as an R&D scientist, and I had, you know, sort of limited knowledge with programming and software development. But just because you're generally part of a smaller team and you're limited in the manpower, everyone sort of has to contribute in whatever way they can. But it also gives a lot of opportunity for you to learn new things. And so I learned several programming languages, and to the point where you also learn how to develop code that is ready for release, right? So not just like side project, hobby, I made an app, but like code that is actually very robust and stable and can be used by, you know, thousands of users without breaking down, which is a lot harder, a lot harder done than said. And so the other thing that I wanted to highlight is that because you're working as part of a small team, you also need a team that's very varied. So you have different people who are experts at different things. And because you're all working together, you learn from each other, and you know, you all become interdisciplinary, which is a really nice side of working for a small tech company. But along with that, you also get a lot of sort of responsibility because you're a smaller team, and everything you do, you know, may turn out to be an entire module that will be client facing in the end. And so it's your responsibility to make sure that that works well, and, you know, to make sure you put good effort and, like, you know, take care of the details and things like that in all your work, right? And like I said, I want to make it very clear that every employee has a very direct impact on the company and its success. So, you know, it's something to keep in mind. Like, if, you know, it is a lot of responsibility, but it also can be very exciting. And the other thing with working for a startup, and particularly a tech startup, is that you will very likely get a chance to work on several you know, research projects that are patentable. So you'll probably get to learn the patenting process and how to write a patent and how to you know, how to navigate that space, which is very, very important. And, you know, if you're lucky, you're working on something, you know, some technology that is good and promising, you will get several patents granted. And that will also look good on your resume for the future, right? So it's also something that helps you moving forward. Along with everything else you learn, right? You really get to, you know, expand your resume working for a startup in most cases. And it's very nice, both like to learn professionally and also just to expand your qualifications. And so that's sort of most of what I want to talk about. In terms of the everyday life, you can imagine almost the kind of stereotypical experience working at a startup. You're in like a kind of big open space. Everyone's going from desk to desk, talking with each other, and, you know, you need to focus on something. You throw your headphones on, try to, you know, be focused and work for a few hours, do your thing. And there's a lot of collaboration, basically, is the key thing that I think you will see in a lot of startups. That's obviously changed a lot since the time of COVID, let's say. So we're all working from home now, but a lot of the same dynamics exist, right? So it's almost like a digital open door policy. You can always message. I mean, of course, during reasonable times, you don't want to message someone at 10 p.m., but during reasonable times, you know, you message your coworkers and say, hey, can we just chat about this or that? I'm having this issue. And, you know, it's a really nice experience to kind of have everyone available and just be able to, you know, just interact with everyone. It's a good experience that's not necessarily available in every company, right? Sometimes you're, depending on the size of the company or what you do, you might be kind of siloed into a particular department or a particular group of people. So it is, you know, it's something very nice, I would say, about the experience. And so, because now I've only been I've been out of school for just a few years. This is all sort of I have to offer, but, you know, feel free to ask some questions. There isn't much more to the presentation.
Yeah, thank you for that, Mr. Eros. yeah, we'll just take a little time to see if anyone has any questions.
Yeah, of course, of course.
A little appreciation from Bridget.
I'm not seeing any questions coming up from anyone else, but I might jump in if that's all right.
Yeah, of course.
So I think
a question.
Oh, all right. We'll let the other question go through first.
Okay, so Andrew, I think Robertson, right? I remember our alumni. He says, do you find malls are more interested in your software because of the pandemic?
It's honestly, it's been a little bit difficult because they have much less clients and they're obviously in a very tight spot financially, a lot of them. So we've actually been working more with like other venues, I guess. I mean, I can only speak to a certain extent regarding like business operations, but in general, it's been more work with other venues in this past year as opposed to malls. We've followed up with contracts we already had in progress and, setting up the deployment and all that. But in terms of, it has been a bit more difficult for them. And so naturally you've seen a little bit of restraint in terms of new spending and, contracting new services.
Okay. Well, I guess if nobody has any questions. Oh,
all right. Oh, there's a big one.
Okay.
Oh, all right. Someone just tossed up a description.
Okay.
Yeah. Can I go ahead?
Oh, sure. If you have anything.
All right. So first off, thank you very much for an excellent presentation. It's very interesting that you're working on like tracking people movement through buildings and indoor spaces, because that's actually sort of what I do for my thesis as well. Mine's more from a transportation and modeling perspective. And I'm just wondering how accurate the technology is for like tracking someone as they move through a room and perhaps like their trajectory. Is it something that we could use? Oh, sorry.
Yeah, well, it kind of also depends, right? So you could talk about tracking when they're actually using our app, then you'll get very accurate tracking. So somewhere in the neighborhood of 1 to 3 meter error for 90% of the time or even more. Again, depending a little bit on the deployment and sort of what data is available to the app at the time. And you can also make additional like findings based on, so there's the people who use your app, and then you can also make certain assumptions that out of the entire population of people visiting the mall, only a certain subset will be using your app. So you can sort of make extrapolations on that as well, which are, a little bit less accurate, but it allows you to get a better idea of the whole environment as opposed to just the individual users.
Awesome. Yeah, super cool. I have a
question. Sorry, it's Aaliyah. Sorry, I wrote my paper stuff on that. Sorry, I was trying to copy paste the question I had. So in your field, what challenges are you seeing, like coming out of the pandemic? Like, is there any changes that you're noticing?
I can't say it's changed too much. I mean, besides the fact that there's very few people in larger buildings nowadays, so just the occupancy has gone down a lot, but we kind of expect all that to begin again because these are generally more social venues. So it's not like, the majority of our clients are not things like office buildings, right? Okay. So that might change after the pandemic if you get more working from home and all that. But a lot of the buildings and venues that we would service are not in, we don't really expect a lot of change. It's just kind of a pause now for some of them, like malls in certain cases where there's lockdowns imposed or, it's just harder times. But there isn't a big change in that sense. For us, the majority of the changes we have to kind of work and adapt with is the changing technology. So whether it's things like the software on like Android and iOS changing, and that changes certain accesses that we have to whether it's different data that's available, or certain things get changed due to, just the evolution of the operating systems, right? And we have to constantly adapt to that because, we can't force everyone to use, an operating system from 3-4 years ago, right? So that actually has had quite a big impact and has been a lot of, what we have to adapt to, let's say.
Okay, thank you. I'm so sorry about that.
No problem. No problem. Every question is a good question.
We have another question in the chat by Suyang Han. Is Mapsted expanding and going to hire some employees with a background of data analytics and data mining in the near future?
I believe we have in the past looked for those for someone in that sort of category. I don't believe we found one at the time, but I do believe there will be something. I haven't actually looked at the job board because I expected this to be more of a kind of, just more about my experience as a whole. But particularly, I think as we get closer to the end of the school year, so probably I would say around, February, March, we do have postings, for example, also for co-op students. We have hired co-op students in the past as well to get some experience and whatnot. But that is very likely the type of job that we would have. So someone in data analytics, data mining. As we are compiling more and more data, we would like to continue to offer newer and more interesting, more valuable products from that data. So the answer is yes. I can say like a fairly confident yes.
Yes, I hope we can get in touch in the later today. Yes.
Yes, yes.
Okay, last question. After this, just message Eros if you guys have any more questions. But Professor Costas asks, hi Eros, nice to see you and thank you for the presentation. May I ask what type of positioning / location technology you use at Mapsted? If you can tell us, of course. Is it based on a mobile phone?
Yes, so our positioning system is based off of mobile devices. So essentially whatever is available on a mobile device is what we use. We have expanded to some other solutions using other sort of dedicated hardware, but those have sort of only been in the development stage. So they haven't become sort of full-fledged release-ready products. So essentially our positioning system will take advantage of all the data that's in our that's available on a smartphone. So whether it's inertial sensors and the phone's IMU, to wireless signals, to things like atmospheric sensors like a barometer, right? All of that can be used and can provide some useful information for different aspects of the positioning problem.
Thank you, Eros, and nice to see you again.
Thank you. You as well, Professor. It's a pleasure.
If I can ask you like a last question before we end the Q&A.
Yeah.
So someone from YouTube asked, what security risks do you take into account when developing the software?
So, I mean, in terms of the data itself, we make sure, I guess, from our perspective, it's more of a privacy concern. So we obviously don't want to make, identifiable. We don't want user data to be identifiable primarily. So you don't want to keep track of, let's say, people's names or any identifiable information. So first you want to randomize the identity of a user. And then we also take steps to make sure the data is sort of encrypted and, so to kind of ensure that whatever data that we do get and then, in order to create the products that we do create, it doesn't infringe on sort of people's privacy in that sense. And part of the changes that we have sort of had to adapt to has also been based off of, how the operating systems have evolved the data that they make available based on privacy concerns, right? So, for example, like, I don't know what else I could say in that sense, but from a security perspective, it would be that we don't necessarily have things like, live tracking of people. So it's not like we have a kind of master module where, like, let's say the property manager can pinpoint to the exact user and follow them around the mall and so on. So, we don't, that's not sort of what we do. It's more just insights about, hey, your customers were here, this is what they did, like, need to help them also, advertise their products better and understand the value of, let's say certain areas of the mall and things like that.
Awesome, thank you. Especially because like surveillance is in private spaces such as malls is like, it's really important and can be like unjust at times in different parts of the world. So it's important. Yeah, it's good to know. Thank you so much.
No, they're very welcome. And yeah, we definitely understand that. And we understand that we're kind of in that space where we do have to be careful with, for example, what we collect and how we deal with the data that we collect. So yes, it's very much something that sort of, on our minds as our product was developed and as it continues to evolve. But yes, thank you for the question.
Okay, with that, I'm going to announce our third round of raffle winners. So, for the winner of the $20 Amazon gift card, we have Abdul Vasit. So congratulations, Abdul. For the winner of the ESRI GIS license, we have Lex McGillis. So congratulations, guys. Okay, now I'm gonna introduce our ESRI App Challenge runner-up winners. So first we have Aman Ula. Aman is a second-year master's student in the Department of Earth and Space Science and Engineering at York University under the supervision of Professor Jadidi. His research interests are focused towards achieving interoperability of heterogeneous geospatial datasets, BIM, and GIS, integrated with Internet of Things data using semantic web approach. Our second runner-up winner is Amir Nurbakish. Amir is a graduate student in the Department of Earth and Space Science and Engineering at York University. He's experienced in computer vision, deep learning, network analysis with a focus of location-based services. Currently, he is learning quantum computing, and he is also my TA in our GS course. So shout out to Amir. Suyang Han is our last runner winner. Suyang is currently working towards his master's degree in the Department of Earth and Space Science and Engineering program and expecting to graduate in December. His research focuses on modeling vessel behaviors by clustering AIS data using optimized DB scans. So congratulations to them, and the floor is yours. Sorry, man. I think you're muted.
Can you hear me now?
Yeah, you're good.
Perfect. Okay. Hello, everyone, and welcome. It's been a great day. We had a great presentation. My name is Aman, and I'm a member of our team, GeoNerdHerd. We were participants of ESRI Canada Center of Excellence App Challenge 2020, and we made a web app with the name of Toronto Healthcare Query System. You already have a little introduction of our team. As Jiang Han, myself, Aman, and Amir, we were given a 1 week for this app challenge, just like the other participants all across Canada, and we collaborated remotely for this particular challenge, and we all are master students. So for the app challenge, what we had is the topic for this year's app challenge was about the health. And for this app challenge, we came up with the idea of a digital system for the users to look for the best healthcare services in the neighborhood of Toronto, which is kind of a problem that people face on a daily basis. So we came up with an idea of developing a web application that can support that kind of a problem. That kind of a solution. Oh, sorry, solution to that kind of a problem, sorry. And so for this particular app, we designed 3 ways. Is first we get the resources from the Toronto services, which includes the clinics and hospitals. Then based on that data set that we had, we use the location intelligence for the visualization of that information. And lastly, we had we designed a dashboard-based layout, so we can have like the filter information, which can give us some kind of a informed decision making regarding the matrix of average waiting time, for example, what kind of patients have when they visit the hospitals. So just to get like the complete overview, I will just play the video of what we had made for this app challenge. So it will give more broad perspective of what the app is about.
Do you know how long wait times in emergency departments of hospitals in Canada can be? Or how difficult it is for someone to locate the right medical facility nearby providing the treatment they are looking for? Imagine a person is looking for urgent medical assistance and searching for a medical facility nearby. What is the first thing a person thinks about? Is it a good treatment or the location? How far is it? Availability of the doctors? And is it easily accessible? Usually people visit clinics or hospitals in case of emergency without knowing the period of time they will have to wait before getting the treatment, or the length of time the person will spend in getting the treatment. That is, from the moment they enter the hospital to the moment they will leave. A person will be constantly thinking of these factors but might ignore them to get the treatment from the medical facility. Most Canadians share the experience of significantly long wait times and length of stay in hospital emergency departments. Data collected from a period of 2011 to 2017-19 shows that the patient Equity, Ontario, the average time spent a significantly long time till the next day. A survey conducted in 2016 of Commonwealth countries shows that 29% of Canadians have waited for 4 or more hours the last time they went to the hospital emergency departments. Considering the magnitude of the problem, what are the possible solutions that can be adapted to resolve the issues? How can we help the patients that are looking for better treatment, finding the right medical service, and spend less time in emergency departments of hospitals? Our team of geomatics engineers at York University picked the idea of the ESRI Canada 2020 App Challenge and thought of developing an application that provides insight into the waiting time and length of the stay in emergency departments of the hospital. The application also supports location-based services that filter medical facilities, which in turn can help in better decision-making for the patients. Now let's take a quick tour of our application. We developed a website that showcases our application for facilitating users in health query services. By clicking on the Explore app, you will be navigated directly to the application dashboard. Here, you will find a map with marked medical facilities, details, multiple filters, and some charts. What if someone wants to locate a dental clinic with 2.4 Google Maps rating? Or they want to locate the hospital nearby. And find the details about that hospital in terms of wait time from the first assessment by the doctors till the time it takes for the patient to be admitted, or in case of other emergencies. We have also applied a filter of hospital level to check the waiting time and the length of the stay times for each emergency category. The detail level information is extracted from the open datasets to help the user understand and make a better decision by considering the wait time and the length of the stay in emergency departments of specific hospitals. We have also developed Survey 1-3 applications for the user feedback on their visit to the medical facility, with an aim to create a better experience for the user in the future. The medical facilities to share updated information that can help in dividing the load of the patients treated in the emergency departments of hospitals in Toronto and across Canada, to spend less time in emergency departments and make our health system better and easily accessible.
So this was like the complete, the whole app challenge video that we had. We submitted this as well. I will just share the live link of the our whole app that we made on the chat. I will ask my team member Zhu Yang if you can share the link with the of this with the chat as well. This is the landing page that we have, and we also added 2 more features that were not really described well in the video that we had. Was the 2 features of having a feedback from somebody who is visiting the medical facility. And
sorry, Aman, I'm going to have to interrupt you right there. You may have to stop your share and reshare the page that has your live demo running. We can just see live demo on the screen right now.
Oh, okay. Sorry about that.
Yeah, no worries. Just going to check in with that.
Yeah, cool. Okay.
Beautiful.
Perfect. So this is the landing page of the web app I was talking about. These are the 2 features that I was discussing that we added separately, and these are the ArcGIS Survey 123 forms. They're basically built for the people who are the patients who are visiting the facility, and also the other Survey 123 form is for the providers, who are the services, basically the hospitals or the clinics, so they can have their kind of feedback on how many patients are visiting, what are the time slots, and all of that. And if you can go to the Explorer app, you will see the same dashboard that we have explained before over here. And it's quite interesting to see how much patients visit monthly and annually and even per day in all of the facilities that are there in just Toronto region. So yeah, so if you want to apply some filters, for example, we are looking for the stats about the hospital for sick children. We will see how many patients visit like in each month, and basically what are the times that are spent on average in each category. Therefore, 5 different categories, the low urgency, high urgency, and the first assessment by the doctors. They're just about details about how the healthcare system works in the hospitals and clinics. So feel free to explore, and I will just head back to the other slide part. Where did we go? Oh, yeah. Okay, so yeah, so these are the resources that we used for our web application. The resources that we use are all open source. The data that we use is all open source from Canadian government, Toronto region, Ontario region specifically, and we use the ArcGIS dashboard layout theme to build this particular application, and we had like some Python scripts to get the data in particular form, so we can have it like filtered version of it in representation. And with all this video and all the app we made, we stood at the first runner-up position. Our team made it till there, and I would really like to thank my members, team members, for being with me in this team and participating, and Michael for their support and considering us as like the first runner-ups, and our professors, Professor Majid Jadidi and Professor Costas, for giving us this opportunity. And these are the links that are available. And I'm here if you have any questions to ask.
Okay, thank you, Aman. Thank you, Amir and Sian. If nobody has any questions or would like to say it later, their emails are there. I'm going to continue along with the fourth round of raffle winners. I'm just going to announce them as soon as we have our slide ready.
Has it not come up?
Thanks. Okay. All right. So for the winner of the $20 Amazon gift card is Mary Nguyen. For the winner of the ESRI ArcGIS license is Sahib Verdi. I'd like to say I don't pick any of these winners. Michael Yamin, of the CFO of our Geomatics Club, does that. So you can send all the hate mail to him. Okay, so with that out of the way, I'd like to introduce our graduate students. First, we have Hamid Kiavars. Hamid is a PhD student in geomatics engineering working on knowledge discovery in 3D spaces using BIM and GIS data and the application of energy efficiency at Lausanne School of Engineering, York University. He has a master's in geomatics engineering from the University of Calgary and University of Tehran, Iran, and civil survey engineering from Iran University of Science and Technology. Our second graduate student is Uchas Saha. Uchas is a master's in civil engineering student at York University working under the supervision of Dr. Kevin Gingerich. His research interests include transportation planning, freight transportation, traffic modeling, microsimulation, operation research, and system analysis. And our final graduate student is Sarah K. Kofsravi. Sarah is currently a fourth-year PhD candidate in the Department of Civil Engineering at Lausanne York University. Her research interest is flood management, geospatial data analysis, sustainable development, green infrastructure, sewer systems, and hydraulic structures. So, graduate students, the floor is yours.
I do believe for this section, if I am not mistaken, we actually have a bunch of video presentations to show you from the graduate students. Am I correct in saying that, Ryan?
Oh yeah. We also have also our ESRI Challenge runner-ups, their videos as well. So I guess we could show that.
I only have one video file, by the way. You only sent me one.
Oh yeah, it's
It's the same one?
Yeah, it's all compiled together.
Brilliant. So I'll bring this in. Actually, 1 second while I optimize this so that you guys get the best experience possible.
Hello everyone, my name is Amir and I'm a graduate student of geomatics in the Department of Earth and Space Science Engineering, York University. Currently, my focus is on spatial quantum computation for graph optimization. Quantum computers are not just a more advanced version of our current computers, they're something entirely different. A quantum computer promises to completely transform computing as we know it. Also, quantum computing has already been on an exponential growth curve in terms of its power. So nowadays, a memory unit that can that helps you to compute one of these bits is the size of an atom. When we get to quantum computers, we go to the subatomic level, which completely transforms the way computers operate. In a computer or in a classical computer, you can either have 1 or 0 in a bit. However, in quantum computers, we can have 1 and 0 at the same time, and we call the smallest component in quantum computers quantum bits or qubits. Qubits are often made out of subatomic particles, usually photons, electrons, and ions. And what happens at the subatomic level is that a particle can stay in multiple locations or in multiple states at the same time. What might happen if you flip a coin and it started to spin around while it is in motion? The question is it tail or head? So the truth is, we might say it's both. The probability of being tail and head at the same time is called superposition. This superposition basically gives us computing power that could be over 1 million times faster than even the fastest supercomputers today. There are many areas where our current computers really struggle and where quantum computers could have a chance to shine. The first is optimization problems. Current computers need to explore every possible solutions until it finds the most efficient solution. This process would obviously be incredibly time-consuming, especially if we have more complex data and more complex data are factored into the problem or into the equation. However, a quantum computer, in theory, could explore every possible solution simultaneously before presenting the most efficient solution. Optimization problems hold immense potential for emerging technologies like self-driving cars, where a master system could theoretically assess all the moving vehicles, traffic patterns, stop signs, and potential road hazards all at the same time. Quantum computation can be used on graph optimization problems. However, the thing is, it's not possible to run a classical algorithm on a quantum computer. It needs to be reformulated to be able to use the whole potential of quantum computer. And this is my challenge in this research. And it brings us to our topic, which is titled Spatial Quantum Computation for Graph Optimization. We are still on the first step. So many things need to be done. And stay tuned. See you next time.
Hello, everyone. I am Xuyang Han. It's a great honor to present my research at GIS Day. My research topic is vessel route clustering and the trajectory anomaly detection by optimized DB-scan. Marine transportation has very high volume. By statistics, about 70% of marine accidents are caused by human error. So one of the ways to make marine navigation safer is to reduce the reliance on human intervention by equipping with autonomous systems on the auto vessel. Systematically modeling and surveillance on vessel behaviors should be of high priority in the marine transportation domain, as well as auto vessel research. The reliable data sources for generating nautical routes are automatic identification system data. This research will focus on modeling the vessels by clustering the marine trajectories from historical AIS data. This model can predict what is the normal range of velocity and the direction of this vessel, where it is possibly going, and the model can detect if it is an anomaly, such as unexpected collision or smuggling. DB-scan is one of the existing clustering methods that can potentially be applied on trajectory clustering. Because DB-scan is good at two things simultaneously, clustering the data by spatial density and detect outliers, just as shown in this figure. Here is the overview of the research project. First, the input is open source historical AIS data. After pre-processing the data, I optimize DB-scan in these three aspects. Define novel representations of marine trajectory data, integrate Mahalanobis matrix to DB-scan, a method to select optimal parameters automatically. Then the optimized DB-scan is applied on the AIS data to generate output model. This figure shows how the model is generated by applying the proposed clustering algorithm to historical AIS data. Behavior patterns of marine transportation traffic are profiled based on the clustering results. Those clusters are used to model the AIS data within a certain region and monitor vessels installed with AIS equipment. The model provides a monitoring purpose for manned vessels and determine if the vessel has some anomalous behaviors. Automatic vessels can also take advantages of the model for planning the route from selecting sequential clusters and getting recommendations for actions. I believe this research can bring new possibilities on DBScan, which contributes to machine learning research community. Also, the model is perspective to contribute to marine transportation in Canadian waters. Thank you for watching.
Hello, this is Hamid. I am a PhD student in Department of Earth, Space Science and Engineering. I'm going to introduce my research with the title of Knowledge Discovery in 3D City Model and Building Information Modeling, we call it GeoBIM. Urban and population growth result in increasing the pressure on the public utilities like transportation, energy consumption, healthcare services, crime management, and emergency services in the realm of a smart city. A smart management of these services increase the necessity of using enriched urban information. These matters enforce the urban manager to use 3D spatial data using 2D information to solve the complex problems in urban analytics. In the last decade, by emerging of new 3D data structures such as 3D city model, the geometrical and semantical information are available easier for urban analytics. These kind of data models provide rich indoor and outdoor information of building and city objects. These valuable data sets encourage the urban manager to employ 3D data structure in their decision-making process with data-driven methods like machine learning algorithm, which causes more accurate and realistic results. Here is my research problem. Because most of the machine learning algorithms are established and mature based on 2D data in urban analytics, but they hardly can digest the 3D information because of their complexity in data structure. To solve this issue, our research proposed a framework to generate a city knowledge graph to make simpler data structure from 3D city model and be compatible with machine learning algorithm. The knowledge graph includes geometrical and semantical information as an attribute of nodes. Also, it contains the relationship information or topological information between the city objects. Our research is working to improve this framework to provide an accurate city knowledge graph to feed graph-based machine learning algorithm for a realistic result in urban analysis application, such as energy consumption of buildings in city scale. Thank you for listening.
Hi everyone, my name is Utsav Shah. I'm a second-year master's student at Department of Civil Engineering here in York University. I'm currently working under the supervision of Dr. Kevin Gingrich, and it is my utmost pleasure to present in front of everyone for this year's GIS Day. Today, I'm going to give a short presentation on the application of our GIS in freight transportation sector. Here is a short summary of a part of my master's thesis. For my master's thesis, I'm looking at the route choice of long combination vehicles, or also known as LCVs. On the right side of the screen, you can see a video showing the difference between a normal tractor trailer and a LCV. As you can see from the video, that the LCVs are fairly large vehicles, and they were introduced in Ontario by the Ministry of Transportation back in 2009. And since then, they have gained enormous popularity. And as a result, currently, the MTO is looking forward to extend the number of license permits for this vehicle category. As part of my master's study, I wanted to look at the current MTO approved LCP route pattern and to find if there's any inadequacy in it. So to solve this problem, I decided to use network analyst tool of ArcGIS. The reason for choosing network analyst tool was that it uses a specific algorithm, which is also known as Dijkstra's algorithm approach, to find the least cost path. For example, using this Dijkstra's algorithm, you can find the path with the shortest travel time among several paths. This plays a vital role to balance the demand and supply in transportation sector. Now I'm going to demonstrate some of the works that I have done using network analyst tool for this study. I'm going to switch over to our GIS screen for this purpose in just a sec. Here in the ArcGIS screen, you can see the base map showing the boundary of Ontario and the current MTO approved LCP routes, which is the deep green line. After plotting all the necessary origin destination pairs, I ran the network analyst tool to find the shortest path between various zones in Ontario. For example, here you can see the light green line shows the shortest path between Toronto and Niagara. After comparing the shortest path with the existing route, I found out that there are portions of roads that are currently present in the shortest path, but not on the approved route. And the finding of my study is that adding them in the existing approved route can help solve the problem of route inadequacy. That's all from me for today. Thanks for listening to my presentation. Hope you guys enjoyed it. Have a good day.
Hi, my name is Sarah. I use geospatial analysis for flood management purposes. One of the major components of flood management is building a hydraulic model for the catchment. To do so, we need input data, which are mainly three categories: climate data, data related to the geography of the catchment, and also low impact development data. One of the main measures in low impact development techniques, or LID, is using LID infrastructure to capture runoff at the source, and instead of allowing it to flow down a stream and be collected through pipe. To use this kind of infrastructure, we need to answer questions such as where we want to use these type of infrastructure and what type would be the most beneficial types in terms of the lowering the cost and maximizing the benefit. In our suggested framework, we incorporated LID benefit and cost into the geospatial characteristic of site using three different indices, and through geospatial analysis of these indices, we created a final index which optimized sites and types of LID. Component A of this method is visibility. As I explained, we just assume the visible sites and what's shaded in gray in our layout. Component B assesses the hydraulic demand of sites for LID sites, meaning that the 25 cell that we have in here, and overlaid with the cost of each type of LID, and at the end generate a demand for each type of LID based on its cost. It's kind of a justified demand. This demand is overlaid with visible sites, and at the end gives us a hydraulic demand in each visible sites. Component C concerns with the socioeconomic and environmental benefits of LID type, which are lateral benefits of LID like air pollution, water quality, which are environmental, and like education and their effects on health system. So we can combine these benefits coming from the sites with the benefits coming from each LID type one by one, and perform a geospatial analysis, and at the end we generated three different layers for three different LID type, overlaid them with the visibility of the site, and at the end we generated three layers that tells us what is the socioeconomic and environmental demand for each type of LID at each location. At the end, component B and C were overlaid, meaning that hydraulic demand and socioeconomic demand were overlaid for each type of LID. and one index were generated for each type, comparing geospatial analysis of these three indices gives us a final optimized layout for the sites and for the type of LID. Thank you.
Hello everyone, my name is Amir and I'm a graduate student of geomatics in
Okay, great videos, guys. I'm gonna announce the final winners of the raffle. So, Tim, if you get ready. Okay. Okay. Oh, I think I. Okay, test. Okay, I'm good. All right. Okay, so for the winner of the $20 Amazon gift card, we have Gloria Hu. For the winner of the ArcGIS license, we have El Gurtet Iman. So that concludes all the winners of the raffles. Congratulations, everyone. Tim Gurjit, I think you guys have upcoming events you guys would like to speak a few words on?
Hi everyone, it's me, Gurjit Mahant, the president of the Geomatics Club, once again. So we have this upcoming event, and it's basically called GeoTalks. It occurs bi-weekly. It's a virtual seminar, which we began this year, organized by Professor Song. And this is our second GeoTalk, where our guest speaker is Dr. Kevin Lim. He's the founder and CEO of Lim Geomatics. He will be sharing his experience about his journey and his research regarding airborne LiDAR and geospatial software and data to help forestry companies. This GeoTalk is hosted on Wednesday, November 25th. It's only 1 hour from 3 p.m. to 4 p.m. Please visit the link yugeomatics.ca/geotalks for more information and to be registered and to be directed to the registration link. Hope to see you guys there.
All right, and hi guys, this is Tim once again, the president of the IT York University student chapter. We also have an event for you coming up. This one is a lot closer. This one's tomorrow. That's Thursday, November 19th from 3:30 to 5 on autonomous vehicles. We have 3 speakers scheduled to come in and give a discussion on the future of transportation in the city of Toronto and abroad. We have speakers from the city of Toronto, Kittleson Associates, and our very own York University. If you're interested in learning more about autonomous vehicles, you can register on campus groups at cglink.me/r892366. Or for those of you who are watching on YouTube Live, take a look at our channel and you'll be able to find that we have the live stream already set up and ready to go for tomorrow. Once again, that's the IT seminar series on autonomous vehicles tomorrow from 3:30 to 5. Thank you.
Okay, I think that concludes GIS Day. Thank you all guest presenters, ESRI Out Challenge runner winners, and all our graduate students. Hopefully everyone here learned a little something about GIS, and hopefully we can see you again next year.
Thanks, guys. It was a pleasure.
Yeah, it was super fascinating. Thanks.
Thank you all for attending and participating.
Let's get a round of applause for all of our speakers, for York University, for Lassonde, Geomatics Club and ITE. Thank you, everyone. Thank you to ESRI for sponsoring us with our excellent donations, our excellent prizes. Thank you to everyone. This has been GIS Day at York University. This stream is now terminated.